Assalamualaikum warahmatullahi wabarakatuh. So this is AC motor drive part 2. Okay. So previously what we have learned is actually we have learned about sleep. Okay. So sleep, which is equal to S, and this one is omega S, which is the synchronous speed minus the motor speed over the synchronous speed. So synchronous speed is actually the flux rotation speed at the stator, okay? While your omega m is your speed of the motor, okay? And from this equation, if we rewrite again this one, we will have omega s, s multiplied with synchronous speed is equal to omega s minus omega m, where this one we call this is actually a sleep speed, or sometimes also this one is also sleep frequency. So if the sleep frequency, so this one is S multiplied with the frequency supply. Okay. We have also learned about the characteristic, the torque speed characteristic of the induction motor. So this is the torque produced by the motor, and this is the speed of the motor. So the characteristic is a non-linear. Okay, it's a non-linear relationship. So if we plot, if we create another axis, which is what we call sleep axis. Okay, so this sleep equals equal to 1, and this sleep is equal to 0. While the sleep of the the speed of the motor, this one is actually 0 r radian per second, and then here is actually your motor speed is equal to omega s. Okay, so when torque is 0, so your omega speed is equal, the speed of the motor is equal to your synchronous speed. Okay. Okay, now my question to you is actually how to determine the speed of the motor. How to determine the speed of the motor. Okay, so the speed of the motor is actually determined based on the intersection between the characteristic of the motor with the torque load. Okay, so the intersection, for example, at this is the characteristic, the torque speed characteristic of the motor here, and you have a constant torque load here, the red color. So the intersection between torque speed and your motor and your load line is where your motor, the speed of the motor. Okay, so from here we can have your sleep frequency. So the sleep frequency is from here to here. So this is your S omega S. Okay, so another question is how to make your speed of the motor change or vary. For example, I want to change my speed, to reduce my speed from this omega 1 to the new speed here. So how can I make my motor speed change from omega 1 to omega 2? So actually, and what I have mentioned to you, that the speed of the motor is determined by the location, the intersection between your torque load and your motor characteristic. So how to change this? Is it by change the torque load here so that it will be intersect here? Okay. So if you change the torque load to determine the speed of the motor, so your answer is totally wrong. Why? Because if you change, because load is the load, you cannot control the load. The load is still a load. So actually what you need to do is actually you need to control your system to meet the requirement that required by your load. So in this case, okay, we are using motor, okay, to meet the requirement of the load. So right now, right now what you need to do is not to change the load, but is actually to change the torque characteristic, the torque speed characteristic of the motor. So if you want to change the motor speed, for example, reduce it to a new value, okay, what you need to do is actually to change the torque speed characteristic of the motor so that it will intersect at that speed. Okay. So this is the torque speed, the original torque speed, and this is the new torque speed of the motor. And here, as you can see, we have the new synchronous speed because we have actually changed this from this torque speed characteristic into this torque speed characteristic. So that is how we met the requirement of the load, okay, by changing the torque speed characteristic of the motor. There are three methods on how to control, on how to change the torque speed characteristic of the motor. The first one is actually by changing the number of pole, okay. The second, so this is the number of pole. So meaning that if you change the number of pole, meaning that you change the location, okay, the location of the synchronous speed. So this is the first method, but this first method is not very popular because it will result in discrete response of the speed change. The second one is by actually change the voltage input. Variable voltage, but the frequency is fixed. This is actually a typical method. Okay, this is the popular method to control the speed of the motor. So if you have went to the machines lab where you are required to have a variable speed of the motor, what you have done is actually you change the voltage input, right, from 240 volt into 100 volt and so on. And this is possible by using what you call the variable transformer. Okay, but the frequency is fixed to the frequency supply of the TMB, which is the 50 Hertz. Okay, and the third one is actually by varied voltage and variable frequency. So this is also popular as VVVM. Okay, variable voltage and variable frequency. So variable voltage and variable frequency, this can be easily done by having the power inverter. So meaning that you need to have a DC. So meaning that okay, So if you have a three-phase supply here, what you need to do is actually to convert it into a DC form by using rectifier. Okay, rectifier here. Okay, so you control alpha here, and then this is also you control the switching. So actually from this one, you can actually produce variable voltage and also variable frequency. So this is can be done easily by using power electronics converter. Okay, so I want to elaborate more on the method of changing the torque speed characteristic, the second method and the third method. So the second method is actually a variable voltage, fixed frequency, and the third one is the variable voltage, variable frequency. So this one is actually we vary the voltage by using variac, and this one we made the voltage and frequency variable by using power inverter. Okay, so the second method is the most popular because it involves the least components and not so very expensive in terms of designing its control, because they are only using the variable transformer to adjust the voltage input for the induction motor. But if compare in terms of the efficiency, okay, the second method is the least expensive, sorry, the least efficient method compared to the VVF. Okay, because it will make your motor, for example, if you reduce the voltage, the speed of the motor will be reduced significantly, and it will actually make the slip value becomes bigger. And if the slip value becomes bigger, meaning that your power factor of the voltage supply will become very low. The current magnitude, the current supply is high. So when you have a current high, so meaning that you have a lot of losses at the internal resistance. Okay, and different with the VVVF. So by having VVVF, both variable, voltage and frequency, we will show that the slip frequency is very, very low and still very near to the synchronous speed. I would like to recall that for optimum operation of the induction motor, you need to make sure that your speed of the motor is very near or very close to your synchronous speed. And the other advantage of using VVVF, variable voltage, variable frequency, is because you will preserve the torque maximum capability. Okay, so the torque maximum capability is much related to the flux that through the air gap between the stator and the rotor. Okay, and this air gap is actually depends on the ratio of the voltage and the frequency. So this one we can say that this one is a voltage supply, and also this one is the frequency supply. So in order to maintain the value of this flux air gap, so you need to actually maintain the ratio between the voltage and the frequency. So if you go to the second method where you have a variable voltage but fixed frequency, meaning that if you look at the equation that relate the flux, okay, with the voltage and frequency. If you change this voltage while the frequency is fixed, meaning that the air gap, okay, the air gap will actually change. So meaning that if, for example, if you reduce the voltage, the air gap will be reduced and so on. So this will actually reduce the torque maximum capability if you are using the second method. But if you are using the third method, VVVF, okay, where the voltage and frequency ratio will always maintain. For example, if you reducing the voltage, you are required also to reduce the frequency. So if you are increasing the voltage, you need to actually increasing the frequency so that the ratio is always maintained. So by maintaining the ratio between voltage and frequency, so we can actually maintain the torque maximum capability of the motor. Okay, so this slide shows the proof why we need to maintain the ratio between voltage and frequency, because the voltage and frequency are related to the flux. Okay, so the method on to actually maintain the ratio of the voltage and frequency is also popularly known as a constant volt Hertz operation. Okay, so this graph shows two regions of the motor operation. So we can divide the motor operation in two regions. The first one is the constant torque and the second one is the constant power. So if you want the motor to operate and to produce a constant torque in the operation, so you need to always operate at this region. And if you want the motor to actually produce the constant power output, so you need to actually operate your motor at this region. So actually the division of the region depends on the base speed. Okay, the base speed. So this is actually the characteristic of the voltage, the characteristic of the torque speed characteristic of the motor. Okay, so actually it depends on the frequency. So this one may be a frequency 1, this one may be frequency 2, this one may be frequency 3, this one frequency 4, and this one frequency 5. So if you vary the frequency and also the voltage, so you will have this torque characteristic, a different torque characteristic. Okay, and if you want your motor to operate at a constant torque region, please make sure that it is always smaller than the rated supply frequency. So usually in Malaysia, the rated supply frequency is 50 Hertz. So meaning that if you want the motor to operate at constant torque region, the frequency supply must be lower than 50 Hertz. And this can be done simply by controlling the inverter switching. And this is actually the relationship between the sleep frequency with a different torque speed characteristic. So if you have a load torque constant here, and this is actually the characteristic of your motor. So if you have a constant torque, so actually all the sleep frequency for different torque speed characteristic is actually equal. And this is actually the relationship of the sleep frequency with the torque speed of with a different torque speed motor with a centrifugal or what I call the quadratic torque load. Okay, so the sleep frequency is not constant and it is actually varies according to the torque load. Okay, and then this is actually the constant torque and constant power region, then all the essential parameters, for example, the sleeps, the relationship between the sleeps, and so on. Okay, and we will go for example. And I think this one, actually we've already finished our topic for the induction motor part 2.